You're in a meeting. On the table is a proposal for a multi-million-dollar upgrade to your facility. New layouts, new equipment, and a re-engineered workflow. The spreadsheets are looking good and projections seem solid. But as you get ready to approve it, there's a nagging question. How do you know it's going to work as planned? In a dynamic, complex environment, how can you be sure? The truth is, with traditional methods, you can't be sure. You're making a high-stakes, educated guess. For years, we've based decisions on historic data. We look at last quarter's performance or last year's throughput to predict what will happen next. But relying only on past data is like trying to drive a car looking exclusively in the rearview mirror. It tells you exactly where you've been, but it tells you nothing about the traffic jam or sharp curve just ahead. A spreadsheet can't tell you how a small delay at one machine will create a bottleneck 2 hours later. It can't predict how a new process will interact with an old one under peak stress. This is why so many promising projects underdeliver on their ROI. The real world is just far more complex than the static analysis can account for. So how do we move from guessing to knowing? This is where we stop just analyzing data and start engineering with it. Think of it this way. What if you could build an identical living digital copy of your operation on a computer? A digital twin of your facility that includes your layout, your equipment, your labor rules, and your workflows. That's exactly what we do. We use our decades of engineering experience to create a dynamic simulation that behaves just like your real-world operations. Once it's built, we can test to validate any scenario, risk-free. We can ask crucial what-if questions. What happens to our throughput if we add 3 more autonomous mobile robots? Can this new layout handle our holiday peak season? If a key machine goes down for an hour, where does the system break first? The impact of this is immense. This isn't just a theoretical exercise. It delivers tangible, measurable results. We worked with a partner who was about to invest millions in a facility expansion. Our simulation showed their proposed design would actually create a new, crippling bottleneck at the shipping dock. We identified the flaw and redesigned the workflow virtually, saving them from a costly failure. For another client, we tested 3 different automation technologies. The simulation proved that the mid-cost option delivered 95% of the benefit of the most expensive one. They moved forward with a clear, predictable ROI. This is the definition of engineering a solution. We are de-risking your capital investment by proving the concept before the first piece of material is even ordered.